Alright, let's quickly summarize the laws of electrostatics. You know that electrostatics is the study of charge at rest, charges at rest. So the first one is Coulomb's law. Coulomb's law, and it says that force is equal to or directly proportional, some kind of constant. The force of attraction between 2-point charges is directly proportional to the charges and inversely proportional to the square of their distance apart. Notice something. Charge is the unit, so it's the same thing as Q square over R square. Now the next one is electric field intensity. Electric field intensity. This is electric field intensity E. This is force per unit charge, and we already know that force is equals to KQ square all over R square. So if you divide it by this, it's divided by Q, and this is divided by Q, and this is the same thing as times 1 over Q. So this is the same thing as Q over R square. So notice another thing about this charge. So once you know that charge is always at the numerator, for all the formulas of electrostatics, charge is always at the numerator. Now, this is almost the same thing with electric potential voltage, which is V equals to Q over R square. Electric potential voltage, this is the work done in moving a point charge from one point to the other. And mathematically, you can say that it is charge per square distance. Now the next one is electric flux. Electric flux, and this electric flux was given by Gauss, and he said that the electric flux is directly proportional to the charge and inversely proportional to the permittivity of free space. So notice again, charge is at the numerator. And the only difference here is that this one is not carrying R square. This one is not carrying R square. It's just permittivity of free space, EO, epsilon 0. So note it. Now moving on to the last one, capacitance. Capacitance is simply charge over voltage. Notice it again, charge. So once you know that charge is always at the numerator, then for Coulomb's law, you have R square at the denominator, then electric field intensity R square, electric potential voltage R square, then the only exception is capacitance and electric flux. So let's do some calculation tonight. Let's do some calculation tonight. Now, the question is a 10 microcoulomb point charge is 25 centimeters away from a minus 20 microcoulomb point charge. Calculate the magnitude of the electric force between them. Now when you hear magnitude of electric force, magnitude simply means value. That is why when we did vector, I told you that anything that has magnitude is talking about value. But if he has I, J, Z, K, you can now say these ones are the unit vectors, the direction. So they give us plus 10 microcoulomb. They give us minus 20 microcoulomb. Then they give us 25 centimeter distance apart. Then they are asking us to find force. You need to know that on no account should you calculate distance with centimeter. Anytime you're given centimeter, you must convert it to meter. You need to know that. Now, once you know this, your microcoulomb, you can calculate it, you can convert it to coulomb by doing times 10 raised to power minus 6 times 10 raised to power minus 6. So you can do that, or you can still work with this since the 2 units was given to you in microcoulomb. But if you want to convert it to coulomb, just times it with what is it called? 10 raised to power minus 6 a million. Negative a million. So once you know this, let's work. Okay, let me go through the question again. The question said a plus 10 microcoulomb point charge is 25 centimeter away. So 25 centimeter away from a minus 20 microcoulomb point charge. Calculate the magnitude of the electric force. So this is the diagrammatic representation. So calculating this, I will now have that this is F equals to the gas, the constant, the electric constant, electric field constant, then Q1, Q2 all over R square, and this is equals to 9. K is equals to 9 times 10 raised to power 9, then times 10, and I told you that this is converting this to coulomb is 10 times 10 raised to power minus 6 all into, whenever you have a negative sign before a charge, ignore it. What that sign is doing is to show you the direction. Ignore it. So just put positive 20 times 10 raised to power minus 6 all over 0.25 all raised to power 2. So when you do this, punch this on your calculator, you have, so when you punch this, you have that force is equals to 28.8 Newton. That's your answer. Let's go over to question 2.